Future of coiled tubing drilling. So coiled tubing drilling has been around for a long time, but it was popularized in the 1990s, mostly in use in Alaska and Saudi Arabia. The best uses for it have been found to be in re-entry of vertical wells to uh, access part of the reservoir that wasn't available with the technology that was available at the time the well was drilled. And its other use is in underbalance drilling, which it's useful for because there's no tripping required in coiled tubing drilling. So formation damage that can accumulate in an underbalanced reservoir while tripping wouldn't occur with coiled tubing drilling. It hasn't been popularized in most areas due to its historic limitations, which I'll go to in a minute, and just the reluctancy of the industry to change with the rotary drilling, which doesn't seem to have too much wrong with it. And the other thing you know about it is that it uses slide drilling instead of rotating drilling for directional drilling, which means that the bit itself cannot rotate. What it is there's a bent sub that's bent at about 1.5 degrees that'll actually spin, and you can set it at a certain angle that you want to go to and then drill ahead from there. So now we're going to look at the bottom hole assembly. The key components we need to look at are the orienting tool, which will change the direction of the bent sub and thus the bit, which will allow you to drill your horizontal if that's what you're doing, and it will also allow you to drill a straight hole by continually rotating the orienter. The next thing we're going to look at is the direction and inclination tools. Those are very important to not get dog legs and ugly looking holes and that kind of stuff. So you need to have good tools there. And then of course the bent sub, which can be bent usually at an angle of 1.5 degrees, which is unique to the bottom hole assembly for the coiled tubing drilling. So advantages and limitations. The advantages, number one, obviously, is that you significantly reduce the drilling time since there's no need to make connections in the drill pipe. It's a little more portable than your standard rotary drilling rig, and as I've already mentioned, there's less formation damage since there's no tripping that needs to be made usually. Disadvantages, you have smaller diameter holes because just weight and size limitations of making the coiled tubing. You can have lockup or unsmooth well bores, especially during in the bottom hole assemblies that work on slide drilling, because there's a lot of vibration that can happen in those thin drill stings, and there's poor weight transfer due to the elasticity of the coiled tubing, which isn't quite as prevalent in a regular drill string, and also the sliding drilling will kind of catch on a rock and then slide some more, and it doesn't transfer straight down like you would have in a rotary drilling rig. And also coiled tubing drilling units have a higher cost per day, so you really need to make them pay off in the time you have them. So what's the best way to use them, and how can we make them better? The solution is already here, and it's technology. First technology we're going to look at is called the pressure pulse friction reducing tool, and it's an improvement on conventional jarring tools. And what it is you can choose your tool based on the size of the drill string that you have, the fluid compressibility you have, and the injection rate that you're going to be using. And the company will mathematically determine the optimum PPFRT that you need to use to constantly make pressure pulses to keep drilling smoothly during your slide drilling. So they've modeled this in certain wells and done different mathematical results with it, and they found that it works up to 15,000 feet, that you can add an additional 700 pound force of weight on bit equivalent, and you can extend your reach in directional wells up to 600 feet. other technology we're going to look at is the solid state gyro, and this utilizes MEMS technology, which is a microelectromechanical technology, which means that it's 1 to 100 micrometers in size, and this is the first of its kind used in cold tubing drilling technology, probably all drilling technology. But what it does is provide accurate and quick measurements of direction, which is very useful in cold tubing drilling technology because of because of the slide drilling technique. You need to quickly know when your bit is off track so that you can quickly get it back on. Otherwise, you're going to have dog legs and such. And this has been found to be especially helpful on the curve from vertical to horizontal wells. So this was put in a 5-well field test. They did horizontal, vertical, and an S-shaped well. They utilized mud and air drilling, and they were actually able to get 5 wells to the depth they wanted within 100 feet, and they've all been productive wells. And the main thing they did was expand the hole size, which has kept a lot of people away from cold tubing drilling. Expanded it to 8.5 inches on the vertical and 6.5 inches on the horizontal. And they even found that the conventional mud drilling instead of air drilling worked a lot better because of the vibration that they were getting from the air drilling. And one more technology we're going to look at is the rib steered motor, which is pretty new. And what it is, instead of using an orienter tool and slide drilling, it goes back to the rotary drilling, and how it keeps the bit on track is with 3 ribs that can extend or retract to center the drill string in the hole. And below that is another tool that allows the bit to rotate based on a power from an electric line. So this is what it looks like right here. You can see the 3 ribs that can extend and retract right there to keep it on track. And these are just some results that was done with this technology in a Hassan Massoud field in Saudi Arabia. You can see that with the RSM motor, they had tremendous gain of days than the expected drilling plan, looking at 18 and 17 days. Finished ahead of schedule, and then they tested it on the control with standard motor on 2 wells, where on one they gained 4.5 days ahead of schedule, and on another one they were behind 2 days on the schedule. So with this technology, we can see that the main problems of cold tubing drilling can easily be improved. Smoother hole and the drilling time and the cleaning ability have all been able to improve by different technology. So in conclusion, the technology is available and needs to be used more for coiled tubing drilling, which can tremendously improve both your well quality and, more importantly, the drilling time and thus the drilling costs. Thank you.